Now we're recording. If they had lost, I would have blamed you. Yes. So, where were we? A standard form of a quadratic function looks like this. F of x equals a times quantity x minus h squared plus k. So those that remember from last year, why is this commonly referred to as vertex form? What do we gain from this form of a quadratic? The vertex pretty easy to find, isn't it? What do you guys remember from last year? What is the vertex? HK, yeah. Vertex is the point h comma k. Now I want to compare this to what our textbook called general form. General form looks like this. F of x equals, this is what you're more used to seeing probably, ax squared plus bx plus c. That's what's referred to as general form. All right, I want you to think back. This was probably your least favorite lesson of last year. Does anybody happen to remember how to go from general form to vertex form or standard form? What's that? 7 times? Well, you better be an expert then. Do you remember what it's called?
Which one?
To go from general form to standard form. I'll start the phrase. You guys complete the phrase. Pun intended. You guys don't get it, do you? That was a math joke. That was a pretty funny math joke, too. All right, the phrase is complete the square. Does that sound familiar to anybody? Complete the square. 3 of you guys are dirty liars. You all learned it last year. Complete the square. Nobody? Man, it's probably because you were too busy texting on your phones last year. Write this down. To write a quadratic, write this down. If I can speak, quadratic function from general form to standard form. You complete the square. Now, completing the square, it's really just an algorithm. An algorithm means it's just a list of steps. You do this first, you do this second, you do this third. It's a process. If you don't do it on a regular basis, you forget it. Once you see it a couple of times, you remember, oh yeah. And you're also going to remember it wasn't that hard to do. It's just it's been a while for some of you guys. And that's why you're thinking, I have no idea what he's talking about. But it really isn't that hard to do, trust me. It's like riding a bike. We good to go? Before I show the whole process, though, I want to talk about something that's pretty important. There's something called a perfect, you need to write this down, perfect square trinomial. It's important that you understand what this is, perfect square trinomial. The better you understand this, I think completing the square is going to be a little bit easier for you, perfect square trinomial. I'm going to put a few of them up there. I want you guys to see if you can figure out what the pattern is, all right? This is a perfect square trinomial. So with just one of them, you probably aren't seeing a pattern, right? Here's another one. They're all written in blue. Nope. There's another perfect square trinomial. You seeing anything? Here's another one. These are all called perfect square trinomials. Is anybody seeing anything here that might classify? Here's one that's not. Let me give you a non-example. This is not a perfect square trinomial. So this is a non-example. Come on, you guys, think. What do you think?
If you count 4x squared plus 4x plus 1, because like it's still the same thing, but it has a factor greater than 1 to 8.
Ooh, you're getting it back. Yeah, we'll talk about that. Hold on that for just a second. Well, let's break this down into more simple terms. What is a trinomial, first of all? Trinomial, tri means? 3. So those are all trinomials, yes or no? Those are all trinomials? But why are some of them perfect square trinomials? Some of them are not. What do you think? What do you think, Rachel?
Because all the third numbers are perfect squares.
You're talking about the constant at the end?
Yeah.
4 is a perfect square, 16 is a perfect square, 25 is a perfect square. That's part of it.
You add up both of them, like 25 square root of 25 is 5, and 5 plus 5 is 10.
Okay. And that's the other part. Did you guys all hear that?
That's a pretty good explanation. Just because it has a perfect square at the end doesn't mean necessarily it's a perfect square trinomial. Like this one here, x squared plus 11x plus 4. This one's a non-example.
Even though it has a perfect square as a constant, it's still not a perfect square trinomial. Here's what. 16, for example, here, 16 is 4 times 4, right? What's 4 plus 4? 8. Or over here, 25 is negative 5 times negative 5. What's negative 5 plus negative 5? Negative 10. So that's what makes a perfect square trinomial.
And even further, I want you to write this down. The way that a perfect square trinomial factors is even more important. This factors into x plus 2 squared. This factors into x plus 4 squared. This factors into x minus 5 squared. That's really the nice thing about these perfect square trinomials is how they factor. Anyway, the reason that's important is you're going to have to form perfect square trinomials. For example, example 1. Form a perfect square trinomial. So for part A, if I give you half of it, like y equals x squared plus 16x plus blank.
What value would form a perfect square trinomial? Which is 64. What do you guys think? Josiah's
Saying 64. We got a yes? Where'd you get 64 from, by the way?
okay. That's yeah. Keep going. You're right. Keep going. And then you just multiply that together by itself. Yeah, there's a little formula I'll show you here in just a second, but memorizing little formulas sometimes doesn't work for people. But you chose 64 because 8 plus 8 is 16, so then 8 times 8 would be 64. Go ahead.
Could you have for a trinomial that doesn't have whole numbers in A, B, C, like x squared plus 2 times the third x plus 3?
You want fractions? Is that what you're talking about?
Like it's not a whole number.
Yeah. Yeah, you could have perfect square trinomials that aren't integers. That does happen. We'll see a couple of those here in just a second. Now, for those that are pretty good at remembering and recalling small formulas, if you want to recall this formula or learn this formula, you can. The number that forms a perfect square trinomial as a constant is half of b raised to the second power. Half of b
raised to the second power. Again, I don't always advocate memorizing small formulas. Sometimes it helps. B is 16. Half of 16 is 8. 8 squared is 64.
Okay. One more real quick, just to make sure we got the hang of this. X squared minus 2x plus blank.
Form a perfect square trinomial. You can either use the formula, half of b squared. We can do what Josiah did. Josiah thought of a number added to itself that equals -2. And then you just multiply those two numbers. What'd you get, Josh? 1. Positive 1? Yeah. What'd you get that?
So use the formula. All right, that'll work. A positive 1. Oh, I forgot. I should have had to do this. Let's go back and factor this. Let's go back in part A and factor this. X squared plus 16x plus 64 factors into x plus 8 squared. It's two identical factors, x plus 8 times x plus 8. What about part B? X minus 1 squared. Now this is just a small part of completing the square. Let's go back. Let's actually do the whole entire dang thing. So example 2. Write the function in standard form. This is exactly how your directions are going to read on the test. Write the function in standard form. There's a set of directions that's implied in this set of directions. It's not explicitly stated. When it says write the function in standard form, the implied directions are to do it by completing the square. That's what you need to, when you see this phrase, write the function in standard form, in your mind you're thinking, okay, how do we do that? By what? Completing the square. Here's the function, part A. F of x equals x squared plus 12x minus 4. Before we do the completing the square thing, let's talk about why. Why not just leave it like that? It looks pretty good like that, x squared plus 12x minus 4. In terms of graphing, though, because we're eventually going to graph parabolas here in a second. If you're going to graph a parabola, would you rather have it in general form like that or in standard / vertex form? What's going to be easier to graph in? Vertex form is going to be easier to graph in because the vertex is part of the function. That's one reason for completing the square. Another reason we're not going to learn until like chapter 8. I think it's chapter 8 or chapter 9 of our textbook. So it's in a little while. But it has to do with ellipses and hyperbolas and things like that. They're called conics. You got to complete the square with those, and it's tons of fun. But let's go through the process. Okay. I might do this slightly different than what you might have learned last year. I've just found fewer mistakes when it's done this way. The problem is this guy right here. -4. Okay, -4 doesn't really fit the pattern. If it's x squared plus 12x, shouldn't there really be a 36 right here? Alright? So what I'm going to do is get rid of that constant. I'm going to add 4 and just put it on the other side for right now, just so we don't have to bother with it. So we have f of x plus 4 equals x squared plus 12x. Now there's that blank spot where the -4 used to be. Now we do what we just did on example 1. We got to form a perfect square trinomial. And I just said it like 5 seconds ago. What's the value? Positive 36. But this is an equation. You do something to one side of the equation, you got to do the exact same thing on the other side to balance it out. So you're going to add 36 to both sides of the function. We have f of x plus 40 equals x squared plus 12. Is this ringing a bell? You guys remember this from last year, completing the square? Anybody? Come on. You should have spent like 2.5 weeks on it. One person, I'm glad, wanted to thank you, Anthony. Well, the point really isn't to write a perfect square. I mean, it is part of the set. But the point is to write it in factor form. X squared plus 12x plus 36. That factors pretty dang nicely into x plus 6 squared. Okay, and I'm going to go ahead and minus the 40. to the other side. And that's our function in standard form rather than in general form. F of x equals x plus 6 quantity squared minus 4. Where's the vertex? Let's talk about that. This actually refers a little bit back to our last lesson.
If we have an x plus 6 inside of a function, right or left? Where's it moving? Right or left? Come on, think. Moves to the left. Okay. Inside the function is opposite, so it's moving to the 6 to the left and down 40.
So the vertex is negative 6, negative 40. If we were to graph this parabola, the vertex is negative 6, negative 40. Okay? That's completing the square. Now you've done a lot of this last year, so we're gonna. That what I would consider more of an easy problem. Let's get a little more challenging here. Let's do part B. Let's throw a leading coefficient in there. 2x squared. Minus 8x. Plus 3. It is the same process that we just did, but there's one teeny tiny thing you got to pay real close attention to. Again, the problem here is this 3 that doesn't really fit the pattern, this constant over here. What should we do with it? What are your... Now some instructors kind of just move it over and keep it on the same side. You can do it that way if that's how you learned it. I just find more mistakes when it's done that way for some reason, just arithmetic mistakes. So I tend just to move it all the way over to the side just to get rid of it. So I'm going to minus 3. F of x minus 3. Now here's where it's different. You guys watching carefully? We have that leading coefficient of 2, which is a little bit of game changer. I'm going to factor out the 2. Just the 2, not the 2x. I'm going to factor out the leading coefficient. Remember, that 3 is not there anymore, so we don't have to factor it out of the 3. If you factor a 2 out, you're going to have x squared minus 4x, and we need to form a perfect square trinomial inside the parentheses. So, what's the value that completes the square, the perfect square trinomial? You're saying 4? Where'd 4 come from? Positive 4, right?
Yeah.
Where'd you get a positive 4? B over 2 squared? All right. Here is one area that I see a lot of students struggle with.
How have we changed the right side? Think carefully for like 5 seconds before you blurt out an answer. How did we change the right side of the equation? We increased it by 8. He's right. Where'd the 8? I can see a 4 right here.
Well, you got to multiply by 4.
It's really 4 times 2. And that is one area that students love to mess up on.
We have to do the same thing on both sides of the equation, but we really didn't add 4. We added 4 times 2. So we have to add an 8 over here to keep the equation balanced. Add an 8 to the left side. Okay? So now we have f of x plus 5 equals, the 2 stays factored out. And now write that perfect square trinomial in factored form. It's x minus 2 squared. Subtract the 5 over. And in standard form, you have 2 times quantity x minus 2 squared minus 5. And now the vertex is 2 comma negative 5. So I'm going to give you guys one to try here real quick on your own. Part C. See what you can make of this one. Go ahead and give that one a try. Hold on, here we go, we're recording. I gave you,
I don't know if it's much more challenging, but it was a little more challenging than the one above it. There were some more ways you could have made some small errors if you weren't paying attention.
okay, so you need to pay attention to what's happening here. Add 7. Okay, so you have f of x plus 7. Then you factor out the negative 3. Okay, and when you factor out a negative 3, you get 3x, or x squared minus 6x. That's the first spot I could anticipate some mistakes happening. If you factor out a negative from a positive, it leaves a negative. So you have x squared minus 6x. And then we have to complete to form a perfect square trinomial. And it was plus 9. But we really didn't add 9 to the right side of the equation. We added 9 times negative 3, which is negative 27. So if you combine 7 and negative 27, you get f of x minus 20 equals negative 3 times quantity x minus 3 squared. And then if you add the 20 back over, you have f of x equals negative 3 times x minus 3 squared plus 20. Okay, where the vertex now is the point 3, 20. That's how you write a quadratic function in standard form. The process is called completing the square. Let's just spend just a few minutes on graphing a parabola. I don't think it's going to take very long. That's our next objective. Graph a parabola.
The vertex comes from here and here. So that moves with its x minus 3 goes to the right. And that moves up 20. And that's what the vertex is, 3 times 20. Okay. And we're going to talk about that right now with how to graph.
So here's what I require. When you graph a parabola on an exam, this is what I'm going to require you to do. First, you got to find the vertex. Okay, second thing you got to do is find the y-intercept. Alright? Within reason, sometimes the y-intercept is way off the graph. If the y-intercept isn't going to work, I'm going to put this in parentheses, or another point. And then the third thing is use symmetry. I'll explain what that means here in just a second. So, real quick example. Let's graph f of x equals 2 times quantity x plus 2 squared minus 3. I want you to find the vertex.
Then I want you to find the y-intercept, and we're going to use symmetry.
Because we want to get the most accurate picture or graph that we can here. So, we got to find the vertex. Isaiah, what do you think? Vertex, where would you say the vertex is? Negative 3 is part of it. It goes down 3. This also affects the vertex. It moves it somewhere. Negative 2. Did you guys hear that? He's right. The vertex is the point negative 2, comma, negative 3. It moves 2 to the left, down 3. That's the vertex. Now, I guess I shouldn't assume. I'm using the phrase or the word vertex, assuming you all know what I'm talking about, because you learned it last year. I know you did, but On a parabola, what is the vertex? I just want to clarify so we're all on the same page. On a parabola, the vertex is
Either the lowest point, if it's facing up, or if it's facing down, we're okay with that? All right.
I shouldn't make the assumption, but the vertex on this parabola is going to be a minimum because it's the lowest point. It's facing up. So we did step 1, find the vertex. Step 2, y-intercept. Now again, within reason, sometimes the y-intercept is way off the graph. Let's just see where it is. You got to let x equal 0. If x equals 0, we have 0 plus 2. 2 squared is 4. 4 times 2 is 8. Why am I doing all the work? This is easy math. 4 times 2 is 8 minus 3 is 5. So the y-intercept is the point 0, 5. Way up there. Now, does anybody know what I'm talking about when I say use symmetry? What the crap am I talking about?
Say that louder.
What do you mean? Yeah, you're right. Keep going with that. What's the same?
From the y-intercept, you go directly
Negative 4, 5. You're right. A parabola is symmetric, so this y-intercept is 2 units away from the line of symmetry. That means it's going to be reflected 2 units on the other side of the line of symmetry. So that gives us a pretty good width there of the parabola.
Now, on step 2, when I say for another point, what if the y-intercept had turned out to be like positive 12? Right, or positive 20? If it's way up there off the graph,
then choose another point. Okay. Just plug in another x value close to your vertex. And find another point and reflect that using symmetry. I went easy on you though. It was already in standard form. What if the parabola's in general form? Now, somebody mentioned, I think it was Zach, you mentioned, well, what if there are fractions? Were you talking about fractions?
I'm talking about
Radicals? We don't want to mess with those. I suppose it could happen, but our coefficients are going to be rational numbers for the most part. So let's do x squared plus x minus 2.
there's a little bit of an issue here. Well, first of all, it's in general form, not standard form. That's not the real issue. Can anybody maybe think ahead here and foresee a potential problem? You're saying something back there. Yeah.
Which I guess really isn't a problem. Fractions aren't problems. Fractions are nothing. I'm going to make a suggestion here. Let's find the vertex an alternate way. We do not have to find the vertex by completing the square and writing it in standard form. Completing the square on this, we would have to use some fractions, which isn't necessarily a bad thing, but it can lead to some pretty simple mistakes. So here's a formula you might have learned last year. It's called the Vertex Formula. It's x equals the opposite of b over 2a. Somebody remembers? All right, this is called the Vertex Formula, the opposite of b over 2a. I would use this formula if your b value is odd. Like where we have now, our b value is 1. This is when I would use the formula rather than completing the square. The one limitation is this vertex formula only gives you the x value. You got to plug that back in to find the y value. Go ahead.
Well, what is plus minus b equal to b minus 4ac? That's the first part of the quadratic, so
That's where the vertex formula comes from, is part of the quadratic formula.
So what's the other part?
Ooh, the b squared minus 4ac. If we had time, I could show you where the quadratic formula actually comes from. It comes from completing the square. If you want to come in after school, I could show you that. It takes a little time, but you might understand it if you see where it comes from. Anyway, x equals opposite of b in this case is negative 1 divided by 2 times a, which is 1. So we have an x value of negative 1/2. So what that tells us is the vertex is negative 1/2 comma something. How do we find that other something? Didn't I just say it like 5 seconds ago? Yeah, if we know what x equals, we got to plug that x value in to find what y equals. Yay, it's a fraction. Super happy, right? So let's try it. Y equals negative 1/2 squared plus negative 1/2 minus 2. We're just plugging in a 1/2, negative 1/2 for all the x's. This is not beyond your guys' capabilities. You're certainly able to handle fractions. Negative 1/2 squared. What did you say? Positive 1/4, right? Is that what you said? All right, positive 1/4, good. Plus negative 1/2 minus 2. Don't you just love fractions? I love them. Now what? Dang it, we're stuck, right? We have to write them all in terms of fourths. If we have 1/4, we can't have negative 1/2. They all have to be in terms of fourths. So negative 1/2 is really negative 2 fourths, and the same thing. Negative 2 is really negative 8 fourths. They all have to be in terms of fourths. So you can, it's really adding like terms. When you're adding fractions, you're adding like terms. So they have to be in terms of the same denominator. In this case, fourths. 1/4 minus 2 fourths minus 8 fourths. It's negative 9/4. That was pretty quick and painless. Which, yeah, for graphing purposes, the decimal might be a little bit better. Negative 9/4 is negative 2 1/4. And since we are going to graph this, the decimal probably would be a little better. Bless you. Anyway, if we're going to graph this, we're going to go left 1/2 and then down 2 1/4, so that's about right here. Now, we started in what? General form? Where's the original equation? Where'd you go? Right here. We started in general form. Not super helpful to find the vertex, but it is pretty dang helpful to find the y-intercept. If it's in general form, your constant at the end, that's your y-intercept.
Okay? Because to find a y-intercept, let x equals 0. If those x's are 0, they disappear, so your y-intercept is negative 2. So that's one nice thing
about general form. We have a y-intercept right there close to the vertex. So that point gets reflected right to there. I know they're really close together, but you have to have a total of 3 points on a parabola to get full credit on an exam. The vertex counts as one, your y-intercept counts as the second one, then you reflect the y-intercept, get your third point. Okay. If you want to find other points, that's fine. I just require 3. Now, ooh, this will be a good review. Domain, range. What'd you say, Anthony? The domain, and this is something that almost all of you messed up on the test I handed back last week. The domain of a quadratic function. Any quadratic function is all real numbers. The domain of any quadratic function, whether it's facing up or facing down, the domain is all real numbers. Range is really depending on where the vertex is and whether it's facing up or down. The lowest point, the minimum value on the y-axis right here, or the smallest y number, is negative 2 1/4, right? Or negative 9/4. Let's use fractions. Negative 9/4. Is there any y value on the graph smaller than negative 9/4? No. So the range is from negative 9/4 to infinity. So that's an alternate way of finding a vertex if you don't want to complete the square. It's called the Vertex Formula. Oh, I know you guys are disappointed. We are not going to have time today for for modeling. Shoot. Are you disappointed? I was really looking forward to it. Dang it. Yeah, we're not done yet. I'm going to give you a couple of problems to work on. Okay, but we're going to have to save modeling till next. Holy crap! When is next time?
Tuesday.
That's a whole week.
Tuesday. It's on Tuesday.
Okay, I want you guys to come in on Saturday, and we're going to talk about modeling. Are we okay with that? We can't wait a whole week. We don't have school on Monday. You have school on Monday? Oh, that's true. Hey, that's right. Technically, this is a UVU class, and UVU doesn't have school off on Monday, so we should probably show. Right, Rusty?
Hey, I don't have whatever feels good.
Do I have that kind of power?
You may have it.
We're coming in on Monday. Sucks for you guys.
Speaking of UVU,
Oh, hey, listen up.
how many are doing this?